My name's Cody. You are all in enhancing application security, understanding and utilizing browser security features. I always try to like do a summary diff of the total length of topics, abstracts from last year. Look at their titles because I'm always really wordy. And this was my like pared down version, and it still looks awful in the H1 there. So. But that's what we're here today. We're going to be talking about HTTP headers and security controls in the browser that anyone, whether it's mobile applications or HTML5, whether it's your traditional .NET and Java, whether it's JavaScript languages, anything that has some flavor of web, you should be able to take advantage of some of the stuff that we're going to be talking about today. So just I'm going to do one of these polling things because we're coming to the end of the day, and I want to make sure you guys are awake. Front-end devs? All right, good. Full stack? Great. Any mobile specific folks out there? No mobile? All right, thanks. Any like managers, leadership, C-level? Cool. Any security folks, pen testers, vuln analysts? A few folks, great. Like I said, I hope to have something a little bit for everyone here. So we'll go ahead and get rolling. Maybe. Try that again. There we go. All right. I'm Cody at KevCody on Twitter. I am from Pittsburgh, Pennsylvania, a little bit north of the city there. I'm a senior application security consultant with Invisium. Invisium was the company that had those like skull T-shirts, and you had to pick some locks and stuff yesterday, and then we ran out of T-shirts, and then they went home today. But I'm still here, and we're gonna have fun. So. That's me. This is my third time speaking at CodeMash, so I love this conference. I was speaking to someone earlier, and I had mentioned that I go to a lot of security conferences. It's all a lot of breaking and Tiger Team pen testing, PowerShell exploits, et cetera, et cetera. I love just going around the conference here and just seeing IDEs up, seeing GitHub up, watching people live code. It's awesome. I love watching people build stuff. And I'm actually specifically an application security consultant, so this is my wheelhouse. I'm a little bit of a vulnerability stumble upon things kind of I fall ass first into things sometimes, but that's me. I'm a mainframe enthusiast. Any mainframers out there? Zero. And I'm a husband, dad, lockpicker, so on and so forth. So today. It's an app world. How can we secure it? So, like I mentioned, whether it's Chromium, Blink Engine, Firefox, Gecko Engine, WebKit, Trident, IE, and Edge Engine, there's these built-in security controls that your applications can take advantage of with little overhead, little effort. And actually, a lot of these, you don't have to do anything at the application level to take advantage of these security controls. So that's what we're going to be talking about today, and it all revolves around HTTP headers. And you might be thinking, like, really? This guy's going to talk about HTTP headers for an hour? But stick with me. I think there's some good stuff here. And we'll go over a high-level overview of that. I was talking with someone earlier and had mentioned that we're probably not going to get into the point of talking about actually configuring the headers. They can be done in a bevy of different places. So I'm going to follow this up with a blog post that actually breaks out if you want to add Lambda edge functions to add some of these headers. If you want to add them at your F5 load balancer, if you want to add them at the app or the web server level. I'm going to follow up with a blog QRG type thing on that. So I'll leave my contact information if you're interested. I will put these slides up if there is a repo. I heard there's not a repo this year. So if there isn't, I'll at least have them up on our blog and GitHub. And if there is a CodeMash repo, they'll go up there as well. So don't feel like you have to take any pictures if you don't want. So what are we trying to avoid, right? So this is the infamous rolling dumpster fire that we're all trying to avoid in app land. But to be honest, I'm a pretty optimistic person. At the end of the day, what we're trying to do is take advantage of controls at every layer in the stack, right? And the awesome thing is that HTTP headers give us an advantage of doing that. So this is what HTTP headers look like in 2008. My code block, for whatever reason, doesn't even fill the screen, but if I scroll down here, they keep going. This happens to be for GitHub. I love GitHub, and they pass like with flying colors as far as header security goes. So if you see me reference them, it's not because they're doing anything wrong. They're actually pretty awesome. But I mean, if everyone can see that, I know it's a little small in the back, but do you even recognize half of these things? There's a lot of just crazy headers in here, like very and XUA compatible, and a lot that we're going to go over here today. So that's where we are today in 2018. Another one, a big one, is Amazon header. So what I did was I took my proxy logs and I literally just grepped for XAMZ and tailed the first 10 lines or something like that, and uniqued it. And these were just random Amazon headers, the first ones that fit on the slide that I came out with. But there's a ton of just Amazon-specific headers out there. Some of them are security-specific, some of them aren't. So I don't blame you at all if you don't ever dive in or get into the idiosyncrasies of headers, because it's a crazy world. But today, our goal is to talk about some of the security-specific ones that can help alleviate your concerns or help mitigate risk at the application layer, because that's where most of us live. That's where I live. So, is everyone still with me? We're just getting started. We're good. All right. So, like I had mentioned, not everything has to be fixed at the application layer. And some things can't be fixed at the application layer. A good example of this, does anyone know what a secure cookie is? A couple people. So a secure cookie, or the secure directive on a cookie, just means that you can't submit that cookie over a non-secure connection. Okay, so if you're using HTTPS, and then for whatever reason you want to send a session cookie over HTTP, if you have the secure directive enabled, that won't ever happen. So good thing is, if someone is in a coffee shop and they try to force you over HTTP, they can't steal your cookie, right? But you wouldn't believe how many times I've been doing application reviews, and I've been in enterprises where they terminate their TLS at the border, and then they turn on the secure flag on the cookie, and all of a sudden sessions stop working because they enacted the secure sessions actually at the the IIS layer or whatever, and they didn't think about the fact that when they're terminating TLS at the border, that cookie flag can no longer, or the cookie can no longer egress back into their application. And yeah, so it's that would be an example of a security directive that can't be done at the application layer or the IIS layer or your web server layer, right? That has to be done further up the chain. You can still tack those things on at your edge. You can still tack those things on at your load balancer. But that would be one example of something that can't be fixed at the application layer. But most importantly, we want to rely on our upstream protections. These things are built into our browsers. We don't have to replicate them at the application layer. So let's talk about some specifics here. It does get a little acronym thick here. I try to do my best to keep the acronym soup low, but if you have any questions, feel free to raise your hand. So the first things first, same origin policy. People familiar with this? I'm not going to go really, really deep into same origin policy, but basically the high-level overview is it restricts scripts from accessing content outside of their origin. This dates back all the way to 95 with Netscape, with the early days of scripts control. And there are some exceptions, so we'll actually talk about CORS, cross-origin resource sharing. You might be familiar with that already. We're going to talk about that a little bit today. There's document.domain, JSON-P, cross-document messaging, which isn't really a security concern, but that is I wouldn't say bypass, but that's a known weakness in the same origin policy. And then WebSockets don't apply for the same origin policy, but they have their own URI binding that they apply to. So if you're thinking like, okay, where are we at with the same origin thing? This is a quick breakdown. So you see here, we have HTTP CodeMash.com, which I think it might actually be .org, but CodeMash.com, sessions Friday. Okay, so that's a valid, that's your domain, that's a valid request. If we tack on sessions Thursday, scripts that are running on that domain can access sessions Thursday. Great, valid call. If we have 8080 sessions Friday, if that is the port that the application is running on, 8080, that is valid. However, if it is a port that the application isn't running on, then it's invalid. So that one's a little bit confusing. But basically what I'm trying to get at here is you have your protocol, your domain, and your port. All of those things have to stay consistent for the same origin policy to work. If you start requesting things off of HTTPS and it was an HTTP application, same origin policy is going to block that request. If you have a different subdomain, so you have 2018.codemash.com, that's going to be blocked. That's a different subdomain. www.codemash.com, where the higher level we were detect codemash.com, etc. So that's the same origin. So that gets us into cross-origin resource sharing. So this is the ability to now utilize scripts and XML HTTP requests cross-origin. This is how we do things in the crazy domain world that we live in today. So it lets a user agent or user gain permission to access selected resources from a server on a different origin. It's currently in use. So we go back to here. Say we had 2018.codemash.com that we were trying to load resources from, and our main app is on codemash.com, just the regular domain. Cross-origin resource sharing is a way that we could utilize script and XML HTTP requests to now properly communicate with the higher level subdomain. So a little bit specifics about CORS. Again, cross-origin resource sharing. XML HTTP requests, or to use for fetch for APIs across sites or subdomains. It's also used for web fonts. A lot of web fonts are on either dynamically pulled down or from different subdomains within CSS or CSSOM. WebGL, images, of course, and scripts. All of this is available on the Mozilla developer site. I use Mozilla developer site a lot for resources in this. I think they're awesome. Obviously, Google, Microsoft, the Azure pages, all that good stuff. They're all great resources. But honestly, when it comes to the W3 specs and the developer specs for the HTTP headers, I think Mozilla is the best. It's plain English. It's really, they give you both implementation guidance as well as what a request would look like. So I highly recommend looking at Mozilla's developer docs. So this is going to be hard to see, so I'm going to zoom in. So this is an example of what a cross-origin request looks like. And they're using something called PREFLIGHT, which I'll go over here as well. Just know if you just have a standard GET request or a standard POST request, you don't necessarily have to use PREFLIGHT. So what PREFLIGHT is, it's this options method that goes out first with some different headers. You can see here the access method is POST, but it has some request headers, xping other, content type, etc. And so what this is doing is it's actually reaching out to the domain with this PREFLIGHT request to see what CORS headers that site recognizes and how you can communicate with that site using cross-origin resource sharing. So the magic here, again, is in these headers. Access control request method, access control request headers. This is obviously originating from the client going out to the server. So this is a request. On the response back to that options request, you're getting back what that server allows you to do, right? So this is like, hey, ding dong, are you there? And it comes back and says, yeah, I'm here, and this is how you can talk to me. This is the language I speak. These are the protocols that I allow, etc. This is all done in your HTTP headers and outside of the body of like a post request. So you can see here on that response that this application indeed allows these methods, post, get, options, and it does allow these headers, xping other, content type, and access control max age. So now the following request after that PREFLIGHT request, our user agent, our browser, can now request utilizing these access control headers or X headers, utilizing cross-origin resource sharing. And the big thing is that this script, whether it's XML HTTP or whether it's in some other type of JavaScript context, you are now able to cross origins outside of your original domain or subdomain that you were speaking on. So let's zoom out here for a second. So these are some examples of these headers and what these cross-origin resource headers look like. So on request from the client outward to this new domain that isn't the application or the domain that we're running currently, you'll see here origin, access control method, access control request headers. On the response back, these are some examples of what the server will then say, hey, this is the language I speak. These are the kind of requests that I'm expecting from you. So things like origin, right? What is the origin? What is the domain that you are sending your request from? Allow credentials. This is a big one. This says, hey, yes, I will accept your cookies that you're sending, or I will append cookies on from my domain, or I will append some type of bearer authentication or a JWT or something like that. So if you have allow credentials true, now those requests that are coming from this other origin can now make authenticated requests to this other origin, to this other domain. This is a big one. Credentials is really interesting. Max page is like a cache thing, methods and headers. So, yes, sir. Correct. Yeah, so it depends on the configuration. You can usually just send an options. If cross-origin resource sharing is set up on the domain that you're speaking to, you can usually just send an options HTTP method request out, and it will respond back with exactly what you're saying. These are the headers that I'm expecting. What usually happens, though, is your application is set to speak to this other domain, so it's already kind of preceding that, hey, this is what I'm looking for. Is this indeed what your response back is? So if you could use the method. You could use the access control allow methods. Yes, and you say this is it. Yeah, you would get a response back saying these are the methods that you're allowed to talk to me over. So it would come back and say get, post, options. You can configure that as far as HTTP response however you want. HTTP responses are actually pretty configurable, but you will still get a response back. Correct. Correct. Yes. Yes. Now, delete is one of those restricted functions. If you just do a get or you do a post, you actually don't have to do the pre-flight request, so you can just speak directly over via get or options or post, and you don't have to wait for the response back saying this is what I expect from you or this is what I allow to do. So I'm getting a little granular there, but certainly we can follow up offline. But yeah, great question. Sure. So here's an interesting thought for you. So we talked about allow origin. So this is where you say that site A is allowed to talk to site B. So if I am on CodeMash.org and I want to talk to 2018.codemash.org or google.com, whatever the case may be, the site needs to respond back and say these are the origins that are allowed to speak to me, via CORS. Via scripts. And we also talked about the fact that there's this allow credentials option. So if you think about this, if you set a wildcard, any origin can talk to me via scripts. Any origin can make an XML HTTP request over to me. And that request will be an authenticated request. It will allow, I'll tack on your cookies, I'll tack on your headers, whatnot. Can anyone tell me what happens here? Yep. Exactly right. So this is so dangerous, and it's actually configured in some frameworks, and it's been so widely abused that the browser will actually say no, you can't set a wildcard origin, and the fact that anyone can make requests and will tack on your authenticated credentials. this is a valid syntax of cross-origin resource sharing, but the browsers have basically stepped up and said, no, we're not allowing this to happen. It's extremely dangerous. So this is kind of the trivia question, or the exception to the rule, where basically if you say any origin can talk to me and they can make authenticated requests to me in the user's authenticated context, the browser just says, no, we're not having that. Okay, so I flew through cores. If we have questions afterwards or time afterwards, happy to deep dive into cores, but there's a ton of different headers that I want to discuss today. So the next one, do folks in the crowd know what cross-site scripting is? See lots of heads nodding here. There's 3 different types of cross-site scripting. So basically, this is utilizing JavaScript in a manner in which an attacker in an error state in which JavaScript was not intended to be executed on a site. So if I'm an attacker, I can basically send JavaScript that's executed in the context of the application that was never supposed to be there. There's 3 flavors of this. There's I send JavaScript over to a site and that's reflected back to me. That's called reflected cross-site scripting. It's not permanent. It's just reflected in that response. They're stored. So basically, say you have a name form, and I put in JavaScript into the name form. That's then stored in some type of backend database or information storage, and then that's sent back to me in the comments field or a forum, or possibly even outside of my session context. That's stored, right? That's being stored somewhere, and it's reflecting back to me. And when the browser sees that script, it's executing that script. And if you're not familiar with cross-site scripting, there's a lot of dangerous things that can be done simply by JavaScript that if we're not protecting arbitrary JavaScript from being executed in the context of your user's browser, it can be tricky. There's also DOM, which is similar to Reflect, except for it's concatenated in the DOM, and it's never actually sent to the server. Outside of that, the reason I bring this up is because there's a really quick win. There's security guys out here like myself who are taking advantage of cross-site scripting, and it's not necessarily a problem that's unsolved or that can't be solved. However, it's not an easy fix in the sense that you always have to do input validation. You always have to do output encoding. You have to find everywhere where input and output is being all the flows from source to sink. So there's this really cool header that you can set, and literally it's just XSS-PROTECTION 1. Right? 0 means it's not on, 1 means it is on. IE, Edge, Chrome, and Safari, WebKit all have this built-in protection. So if the browser sees reflected cross-site scripting that's executed, and you have this header turned on, it'll actually block it. Now I can say that it's not the be-all, end-all. It's not going to solve spaghetti dynamic, all kinds of crazy stuff. But for your bread and butter scripts that were either an attacker sent them in as part of an attack, or somehow they were misconstrued by your application, your browser will protect, one of those browsers will protect you from this kind of vanilla cross-site scripting. And all you have to do is just tack this header onto your HTTP header. There's also this notion of mode equals block. That's optional. So if you have XSS protection set to 1, true, and you also have mode equals block, from there on, the browser won't execute any script from that domain. So it's kind of like the next level of like, hey, this seems kind of dangerous, so from now on in this session, we're not going to execute any scripts from there. Again, it's a quick win. Certainly happy to talk to anyone about cross-site scripting if you're interested, and I didn't do it justice here. One thing to know, Firefox is not in that group. For whatever reason, Firefox does not have the built-in cross-site scripting protection within its engine. Okay, the next one here is X-content type options. So X-content type is basically, are folks familiar with the MIME type that you see, content type? Okay, I see some heads nodding here. So basically what your browser will try to do is it will actually try to pick up that content type and guess where, if it's a PDF, it'll try to render it in the browser. If it's an exe, it'll try to download it, etc. browsers are kind of taking that next leap of usability by sniffing that content type and then making the next step, thinking, yeah, this is what the user is going to want to do when they have this content type come in. If you set X content type options equal to no sniff, that basically stops the browser from trying to interpret what that MIME type is, to where, say, like a piece of malware gets executed in an ad context on a page in JavaScript. If this is set to no sniff, the browser is no longer going to try to just execute that JavaScript or execute that exe or whatever the case may be. So this is really important for both like drive-by downloads or unwanted downloads that are executed by your browser or executed by your operating system. It's also helpful for if you're building an application that has file upload and users are like saying, yeah, this is a text file, but it's really an exe, and they try to like spoof or intercept the traffic and try to mess with the extension. This will actually keep the browser from kind of just pushing that through, and it'll allow the application to actually analyze that and stop malicious uploads. So again, I don't know any downside into setting your content type to no sniff. It's a quick win, and it does really help with the drive-by download. Okay, the next one is HSTS, HTTP Strict Transport Security. How many folks have heard of that or familiar with that? A few folks, okay. So HSTS is this notion that your application only speaks over TLS. You no longer want the user to be redirected from the HTTP page to the TLS page. And there's good reason for that. If someone is in an evil coffee shop, rogue Wi-Fi, whatever, and they just type in, www.codemash.org, even if you have your redirection set to go to HTTPS, www.codemash.org, if they are on a rogue hotspot, the attacker can see that, possibly intercept that, strip off the HTTPS on that redirect, and be able to view your user's non-encrypted connection. So what this does is, think of it like a cookie. If you have this set, this header set, the first time the user connects to your site over HTTPS, on the response back, it sets this cookie. The next time the user mistakenly puts in the non-HTTPS version of your website, the browser never sends that request. You never get the 302 back. All the browser does is it looks back at its own internal kind of cookie jar and says, wait a second, they didn't mean www.codemash.org, they meant HTTPS www.codemash.org. So HSTS is this idea that we only want to talk over TLS. And I'm sure a lot of you in here are utilizing applications that you only want to use over TLS. One other note on that, there is a notion of HSTS preload. Basically, you can submit your domain to the browsers to preload it. This would be like a bank, right? So XYZ bank never wants to talk over non-encrypted communication. So even that very first time in which the browser would spit back out and say, hey, we only want to talk over TLS, even the very first time, the browser already knows that site is only going to be used over TLS, and it never even sends the first request that gets redirected back to HTTPS. So strict transport security is a really interesting concept. It works really well, and if you have a high-risk application, I highly suggest you look at it. Yes, sir? My understanding is it's all based on domain. Oh, absolutely. And just to be clear, I say it's a cookie-like value. It's actually not kept in your normal cookie jar. It's kept outside of your cookie jar for security reasons and other. If you're interested in seeing which sites use HSTS, say you use Chrome, you can go Chrome : // I think it's net internals or view net internals. And you can actually see all your HSTS sites that are cached there. You can delete them if you want. You can modify them, look at them, or whatever. But there's actually a ton of sites out there that use HSTS, both with the header like this or preloaded HSTS. So we're talking about HSTS and TLS, and making sure that our users can trust that they're talking to us only over a encrypted communication channel. There's another header. It's called HPKP, HTTP Public Key Pinning. Now, before we go any further, I'm sure there's folks out here who say, yeah, I've heard of that, but I heard that's no longer a thing. And that's actually true in the sense that Chromium, which is obviously the biggest share of the browser downloads, has said that we're not going to go any further with this. We're actually going to roll this back. We're not going to implement this anymore. I do want to bring it up. I'm not going to harp on it, but I do want to just lay that out there that I'm guessing the other browsers are going to follow Chrome, and this won't be a thing here. And the reason for it is it is tough to implement in a really correct way, and if you do change certificates, you need to have backup certificates and all kinds of crazy stuff. But very, very high level, what this does is when you use TLS, you have a certificate authority. Your browser trusts your certificate authorities. There's some like 400 certificate authorities that your browsers trust. From there, they have an intermediate certificate that they basically give to themselves. That way, if there was ever a breach or something that happened, instead of having to revoke that thing that's hard-coded into all of our browsers, they can revoke that secondary layer. From there, you have possibly another layer or your site's TLS certificate. What HPKP does is it says, you know what? Forget this certificate authority. That's just one more chain in the link that can break that I don't necessarily trust. And what HPKP does is it says, this is my certificate, this, or possibly two certificates. These are the only certificates that my server is going to use. These are the only certificates that my app should trust. Forget about the idea of the trust chain. Forget about the idea of certificate authorities. Only validate that this is the certificate that my users are expecting, and this is the one that they're using. Again, not going to harp on that a whole lot. But the idea is basically just to take one more link out of the chain of trust in which you're hoping doesn't get broken. This is what it looks like in case anyone's interested. Again, it's a header. That's the idea of this talk, is talking about these security headers outside of the app space. But basically, it's just a SHA-256 of whatever TLS certificate your application utilizes. And when it connects on the response back in your header response, it says, hey, make sure this is the certificate that the user is using in their browser, and if it's not, there's no more communication until that's corrected. This can break things like, if you're familiar with like blue coat proxies or middle box proxies in big enterprises, this has some consequences in that. And there's ways around that, but regardless, public key pinning, the whole idea is basically to take the control and trust away from the certificate authorities and bring those back down to your users in your application directly. So now, the reason I wanted to bring this up, there's this alternative, and I think kind of think of it as HPKP Lite. It's not quite as aggressive as saying this is the certificate that we trust and only the certificate. But you can now say this is the certificate authority we trust, or these are the two that we trust, and we only trust these two. This is actually the only thing that I'm going to talk about that's not an HTTP header. This is actually done at the DNS level. So you add a DNS record that says, I trust Komodo and Let's Encrypt. And if someone somehow gets onto your domain and they can get access to verify this out-of-band certificate issuance process, and say they go to VeriSign to get a new certificate. Well, VeriSign, the first thing that they're supposed to do as of September of 2017 is look at this DNS record. And if they're not in this DNS record, no go. You're not supposed to give you a new certificate. So this is just one extra layer in the whole idea of TLS and trusting someone who has the keys for everything else, right? TLS is a really great concept of obfuscating our users and encrypting our users' traffic so eavesdroppers can't see into it. But at the end of the day, you have to trust someone. You have to trust those CAs. You have to trust that other CAs aren't going to do the wrong thing. You have to trust that someone's not going to be breached and create a bunch of certificates for someone else. Because at the end of the day, your browser trusts those CAs. And there's no way for you to really manage that trust level because there's too many CAs for you to do that in any type of non-automated fashion. So again, not a header. Sorry to stray away, but since HPKP is kind of going out the window, this is kind of the next best thing, and it's a lot more loose as far as the control. You can just say, hey, we only trust these guys. Okay, so I went rapid fire there. There was a lot of different XXS and all these different headers. Yes, sir. So the one thing that I would say is the certificate. So the question was, this is all over DNS. DNS isn't necessarily the most secure protocol either. The one thing I'll say is that the certificate authorities are the ones querying the DNS record. So you're not really like attacking the user level at the DNS record. You would have to poison the certificate authority who would be doing that out-of-band checks. That's a little bit more difficult. But I agree, DNS isn't the most secure. These are all defense in-depth layers. And at the end of the day, that's why I wanted to have this conversation with you guys, because all of this is outside of the app space. Everything that you're doing in the app space, these little controls, the no sniff, the XSS protection, the CAA record in DNS, these are things that help mitigate risk that now you can possibly take a little bit of a back seat on in your SDLC or while you're doing things at the app level, because you have some of these layers. But at the end of the day, we want to make sure that our whole stack, everything from A to Z, is as secure as possible. So I do agree with you. It's not nothing is bulletproof. The same thing that a lot of these headers are sent in the responses. If there's an attacker that's in the middle of your requests and responses, they can strip out these headers. And then what good is that going to do? So again, defense in depth, always preaching defense in depth. But a lot of these things are very minimal as far as adding. Like they could be added, like I said, at your border. They could be added at your load balancer. They could be added at your Lambda edge function. And if you can just turn on an option where now that's just a little bit less risk that you have to deal with, I just want to bring your attention to it. A great point. Okay, so everyone's still there. Again, I know we're going rapid fire there. Again, I'm going to follow this up with some actual configuration guidance. So I'm going to talk about the different layers these headers can be added at. I'm going to go over these things in more detail and give you references to each one of these headers so you can parse these out and hopefully get a little bit more than me speaking very rapidly at you all. So, is anyone familiar with CSP? Heard of it? Few folks. So CSP, Content Security Policy, is kind of a cool thing because a lot of the things that I've mentioned so far, the cross-site scripting protection, the TLS safeguards, some of the MIME sniffing, a lot of these, instead of being piecemeal headers, can be done just with one content security policy. The cool thing about the content security policy is there's a ton of power that can be held in just this one header, this one policy. Unfortunately, what that leaves us with is all of these directives that I can't even try to discuss all of these with you here today. And these aren't even all of them. These are just some of them from Mozilla. But what I can do is I'm going to pull up a live site. I'm going to parse out GitHub CSP policy. I'm going to show you a tool that you can go to that actually parses that and shows you whether it's good, whether it's bad, etc. And yeah, we'll go from there. So this is an example of what a CSP content security policy looks like. Again, this is in your header. That first header that we looked at from GitHub, it had this in there. Let's go ahead and I'll show you a live demo of what this looks like. So CSP Evaluator, it's there, CSP Evaluator with Google.com. It's a Google property. It's kind of neat because you can be completely offline as long as you have, this is all done in JavaScript, as long as you have this running. I'm not online right now, but if I paste this in here, it'll parse it out and it'll do its thing. I'm sure you could probably clone it from their Git and do this locally as well, so you don't even have to be online. But the idea is this CSP Evaluator will parse out that kind of hairy-looking CSP policy, and it will tell you the good things and the bad things. So let's zoom in so you can actually see. So if we go up here, you can see default source equals none. Right here, default source, it says none. That's actually a good thing. The next one, base URI equals self. These are kind of key value pairs. They're not JSON, but they're done in a key value pair. here, base URL equals self. So what Google is actually doing is they have the logic built in to know what is a good content security policy, what's bad, and what's kind of in between. And Google is saying that by setting the base URL to itself, which is basically saying my domain is the base domain of what I want to run scripts on, that's a good thing. That's not dangerous. If I had a bunch of base URLs that maybe for domains that I didn't own, that would be maybe not such a good thing. And you'd see the big red flags here when this is parsed out. Block all mixed content. Basically what that is, and again, here's block all mixed content here in the actual policy. What that means is you are only loading scripts and resources via HTTPS. So if you are mixed content mode and some of the things are coming over non-encrypted HTTP, this would basically block that from happening. So again, there's a ton of these: child source, frame ancestors, image sources, script sources, etc. You can parse these all out. And like I said, I really like GitHub's policy because there's a ton of different things they're doing because it's just such a dynamic and large site. But what I can say that I think is even cooler about the CSP policy, above and beyond those headers that we've talked about so far, is that you can enable these CSP protections and then set a report URI to where it'll actually send you whether your users were inadvertently affected by a bad policy. And you can say, so basically non-blocking mode, if you want to think of it kind of like a firewall, like a monitor mode, right? So as our users are using our site, if they're starting to get served up Google Analytics from a new URL that you haven't whitelisted, you'll actually get a report sent from that user back to some URI that you control, and you can actually see if maybe your content security policy is doing something that you don't want it to do or is inadvertently causing stress on your users or your user experience. So again, to kind of summarize that whole thing, content security policy does a lot of what the other piecemeal headers that I talked about previously. It kind of encapsulates that all in one. It's really, really granular, and you can do a lot of very specific things with those. But even beyond that, the cool thing is that when you first run your content security policy, you can just do one directive at a time. Just try this, try that. You can set it up in a warn mode, a non-blocking mode, and you can start to see if your users are inadvertently affected by that and hone that in. And then what you can start doing is once you have a really good content security policy, you can start pulling out some of those other headers that you may not need to set differently now. So I've done a lot of talking about a bunch of different headers and the security implications of that. There are some tools that you can take away today that will help you parse what you're doing now, what you could be better at doing, and the implications of your total security posture by utilizing these security headers. So let me zoom in again. This is, anyone familiar with Observatory? Mozilla HTTP Observatory? A few people. So this is a free tool. You literally just go to observatory.mozilla.org. You can, anything that's publicly facing, you can just plop the domain in, and you'll get a scorecard like this back. The other nice thing is it's in like a full Docker image, and all the source code is available. So if you wanted to build this inside of your enterprise, and you didn't want these things going outside, you wanted to look at maybe intranet apps, you could have this internally and have your teams checking their header security policies completely internal without ever touching the internet, and have this kind of built up here. But if we look at some specifics, here's your content security policy right here. Here is your cross-origin resource sharing, your HPKP key pinning. Here's your HSTS. There's a couple that I didn't even talk about, referrer policy and X-frame options and content type. And here's your X-XSS protection. So basically everything that I've been harping on and going over, there's these tools out there that will do a concatenated scan and look for all of these and see how your posture is currently, and then one by one you can start to hone these in and add whether it's directives for cookies or whether it's the X-XSS protection policy or whatnot. And they're actually weighted into kind of a score So if you go, you'll start off with like an F or something like that if you don't have any of these headers, and you'll see the scores are weighted differently. It's all available on the site. And certain things like content security policy, since that encapsulates a lot of the other headers that we talked about, that's weighted very heavily. So if you have a really good content security policy, you may not have to have some of those other headers, and so on. So that's observatory.mozilla. And there's also securityheaders.io. It's another similar thing. You can see content security policy, strict transport security, content type, X-frame options, cross-site scripting protection. This refer policy is just basically saying sometimes we go from one site to another and we have query parameters in our refers. Sometimes those query parameters can have sensitive data inside of them. If you have a refer policy, you can set it so no query parameters show up in the refer on the next site, the next jump that you go to. So that's something that's I didn't talk about here today, but that's kind of on the up and coming as far as another header. Again, all of these are set outside of your application. All of these are set at your border or upstream at the web server, and they're just defense in depth. They're layers of extra security that you can add on. Okay, so we started with that rolling fire of dumpster fire, and I hope just by talking today, one of those X headers, or maybe all of those X headers, resonated with you as far as just a little way for you to mitigate some risk, a little way for you to mitigate some concern, whether that is like, yeah, I have this application that has a ton of reflected cross-site scripting. If I just add this cross-site scripting protection header on, which will have no impact on the usability of my application in most senses, that's a good mitigating control until we can actually get in and add an input validation routine or output encoding routine or something like that. Or whether it's, yeah, my application is only using TLS. I never want our users connecting to anything over TLS. Let's go ahead and research this HSTS option so that now they don't get redirected every time back to the TLS site. They just connect to the TLS site. You know, by no means am I ivory tower security guy who's saying like, yeah, if you don't have all of this, you have nothing. That's not how I am at all. I highly recommend that you look at these one by one or start looking at a content security policy and just tweaking a little bit. Test it in your lower region. Don't blindly take my my advice and turn on secure cookies and break sessions for everyone in your app, right? That's not the kind of thing that I'm suggesting at all. But I think utilizing these controls that are available at the browser level to reduce the risk of your application is a huge win for you, because now we give developers back more time to develop, right? You're not triaging JIRA tickets from your security folks, or you're not looking at ways to reinvent the wheel as far as input validation routines, or when we were looking at options for this strict transport security thing, we actually wrote a little bit of JavaScript that would parse out the protocol out of the URL and see if you were using HTTP or HTTPS, and if you were using HTTPS in like a forced downgrade attack, basically the JavaScript would then open up another on the next request and force you back over to HTTPS. Again, that's JavaScript that's at the application level. That's not something that you should have to be spending your time. That problem is already fixed. It's a header. It's easy to set. It can be set way upstream of your application, and it has very little implication, you know, at your app level. And one thing that I didn't talk a lot about is if you do have vulnerable code or possibly vulnerable libraries or plugins, you know, like WordPress, right? There's always a new WordPress plugin that's vulnerable and concerning, or some third-party library that does something that's extremely dangerous, and you have to fix it, and you don't know what the implications of fixing that third-party library are, and your security team is breathing down your back to get this implemented. Reducing some of the impact or overall risk of those plugins and libraries would be beneficial just by possibly setting some of these headers and removing that from the application level. And honestly, get that off of your backs. If you're in code all day, have these set upstream, and you don't have to worry about it, right? It's just one more defense in-depth layer, and that's what I'm all about, defense in-depth. So, want to thank the CodeMash staff, all the volunteers, attendees. We're wrapping up here, so thank everybody. If you have a second, please provide feedback in the Attendee Hub app, not just for myself, but for everyone. And I am going to open it up for questions.